welcome, folks, to the second Hemi Engineering AMA. This is not Midweek with Max, so I don't really have to say too much. I'm just going to kick it over to the engineering team, and we'll take it from there. So, take it away, boys.
All right, awesome. Welcome everyone to another engineering AMA. We're going to start making these probably a monthly feature. So choose a week and then every week do this on Wednesday after Midweek with Max, or maybe adjust depending on people's schedules, but this is going to become a more frequent feature. We're also going to do a breakout AMA once we get the BitVM white paper published, to answer some questions about that and have a more in-depth discussion there. So if anyone has... Yeah, go ahead, John.
I was going to say that AMA has homework because you want to read the white paper before it.
Yep, yeah. So we'll give people probably a week after the white paper goes out for the special edition AMA for that. If anyone does have questions, just based on things we've talked about around our BitVM approach so far, happy to chat about those today. But we'll definitely do a breakout AMA for more detailed questions once people actually have the white paper in front of them. So looking forward to that. We did intros of all the people on the engineering team last week, or last time we did the engineering AMA. So I think we can skip doing that this time. Everyone's probably familiar with all the faces on this call. But with that, I will kick it over to Rick, and we'll start going through questions.
All right, sounds good. I have the questions coming in right now. All right, so let's kick it off with HVM. How does the HVM handle edge cases like Bitcoin reorgs when querying UTXOs or transaction proofs in real-time smart contracts, and what optimizations are planned to reduce gas costs for these operations?
Good question. So Bitcoin reorgs, basically the way that HVM works is it lags behind the current Bitcoin tip. Right now that setting is set to 2 blocks. There's actually some security reasons for doing that, besides just making sure DApps don't confirm Bitcoin transactions that could get reorged. It's actually important to ensure that nobody can basically withhold a privately mined Bitcoin block, relay that to Hemi, especially once we decentralize the sequencer. If the sequencer were to also be a Bitcoin miner who is maliciously withholding blocks to try to mess with Hemi's system by getting it to try to process a state transition it doesn't have the data for. So at a minimum, DApps see a state of Bitcoin that's 2 blocks behind the current Bitcoin consensus tip. For different DApps, though, they do need to take into account how to manage confirmations of Bitcoin transactions based on their risk profile. So if they're doing something that's very low risk, like just paying out a Bitcoin miner reward for including a transaction that somebody subsidized in an MBV marketplace, that could work very securely with 2 Bitcoin confirmations. The worst case is a transaction gets reverted and the miner got a reward for putting the transaction and the subsidy goes away. Whereas for stuff like the Bitcoin tunnel, or if you were building, a lending protocol or whatever, in those instances, you want to wait for additional confirmations in your DApp. So a lot of people are probably familiar with the way that Ethereum L2s usually work, which is if the Ethereum chain reorgs, then the L2 reorgs. But because we're combining multiple different chains together, a la Bitcoin and Ethereum, we don't do that on the Bitcoin side. So applications need to be aware of Bitcoin confirmations and only take actions on the DApp layer once a certain action on Bitcoin has reached sufficient confirmations that match the risk profile of their DApp. As for gas optimizations, the HVM precompiles are relatively cheap to call. I forgot the exact gas costs for a UTXO query, but it's relatively low cost. Most of the cost is actually in parsing the return data. So one of the things we did to make it more efficient is we made the UTXO query and some of the other queries, like getting transaction data, for example, customizable. So you can set parameters for exactly the data you care about. So for UTXOs, that's with pagination and page size. With a transaction query, that's being able to say, hey, I only want this input or this output or these outputs, or I want the outputs, but I don't care about having the unlock script. I only care about what the output's size is or whatever. So you can customize at a very granular level what data is actually getting returned so that you can optimize the gas consumption with that. We're also probably going to do at some point a like coding golf or something crowdsourced gas optimization for the Bitcoin Kit smart contract. So once some more features in HVM land and we have more of a stable feature set, we're not adding new stuff all the time, then we'll probably do one of those like coding golf things and see what community member can get the most gas optimized version of Bitcoin Kit and that data parsing.
Optimized while still being usable. This, unlike the traditional like coding golfs, like what people used to do in Perl, where you were allowed anything no matter how perverse, if it was just smaller.
Yeah, there's a balance between readability, usability, and speed.
Yes. Yeah. For production software, it still has to remain like legible to something that vaguely resembles a human being. But that doesn't mean there isn't still cool optimizations people will find out there. And there are still clever things to do, just not too clever.
All right. Sorry for the dramatic pause, but since this is the engineering AMA, I never know who's going to jump in with more technical info. So I'll try to get better at that.
I like the dramatic pause.
All right. Well, I'll just continue with the dramatic pauses then. Second question regarding the HVM. With the HVM white paper nearing release, can you discuss potential future precompiles for emerging Bitcoin features like runes or taproot assets and how they might enable more complex HApps beyond basic DeFi?
Yeah, great question. So one of the future items on the roadmap is adding indexer support for some of the Bitcoin meta protocols, things like runes, BRC20s, ordinals. So that would let people basically have the ability to easily introspect what's going on with those protocols the same way that HVM currently lets you introspect Bitcoin. So like right now, you can ask, what's the Bitcoin balance of this address? And in the future, you'd be able to ask, what's the, balance of this BRC20 token of this address? And so giving that, you can kind of think of the stack of Bitcoin programmability as at the lowest layer, you have actual access to the data, what is going on with Bitcoin, what is going on with the meta protocol. And then on top of that, you have the abstraction layers like Bitcoin Kit that make it easier to use. And on top of that, you have DApps that look at that data and find interesting, creative ways to build DApps around that, whether that be, a tunneling system, whether that be a lending protocol. There's also the potential for, and this is probably less interesting, it's more of a cool thing from a tech perspective, but I probably wouldn't get a lot of use, but being able to take Ethereum assets and tunnel them to Hemi and then lock them in a contract and create a representative token on Bitcoin that represents those assets as a sort of bearer bond that then people could trade around in the Bitcoin ecosystem on a meta protocol and then bring back to Hemi to redeem that underlying Ethereum asset. So there's a lot of cool stuff you can do once we have access to that actual raw data and index those meta protocols. It's a little lower on the priority list compared to a lot of other things we're working on, getting HBitVM working, decentralizing the sequencer, stuff of that nature. But that is one of the future down the road roadmap items is to add that meta protocol indexer support. As for how those apps would be tunneled, or those meta protocol assets would be tunneled, it depends on the type of asset. So basically, you can divide the meta protocol assets into fungible and non-fungible. So your fungibles are, your BRC20 is basically the equivalent of an ERC20 token where each token's the same. They're divisible down to their decimalization. And then you have the non-fungibles like ordinals, NFTs, which are, one-of-one special NFTs. And so the way that you have to manage custodianship, collateralization is different. So for a fungible asset, assuming you have some sort of price feed that you can rely on, you can collateralize those in the same way the current Bitcoin tunnel system works. And so once we add meta protocol indexing support to HVM, we'll be updating the current tunnel vault system to support depositing fungible BRC20s, runes, and being able to use just traditional collateralization methods. With ordinals, since they're one-of-one, it's harder, and those need to be basically valued by the user doing the deposit, almost like buying insurance. So it'd be you deposit a ordinals NFT into a vault. There's a vault custodian who controls custodianship of that ordinals NFT, and then you're buying insurance from them that if they were to steal the NFT, you would get that insurance payout. So you can think of non-fungibles as more of like an insurance system, and then you can think of fungibles as just using the existing approach. For BitVM, once we have BitVM active, it will, and we have meta protocol support as well, you would theoretically be able to bridge any fungible meta protocol assets using BitVM custodianship. The complexity there is the value of BRC20s and the amounts that people would be bringing over are likely relatively small. And so they may not be large enough to justify the overhead costs of a BitVM vault construction. And also, it's a little bit trickier to build a liquidity wrapper around meta protocols, although it's definitely possible. So more than likely, the actual Bitcoin assets themselves, those will all be done by BitVM vaults. And then maybe a few large BRC20s where there's a lot of demand. Those would be deposited through BitVM vaults as well. And then smaller amounts of fungible assets and non-fungibles would use the traditional collateralized custodianship system.
Okay, maybe that was too long of a dramatic pause, but that was for you, John. All right, so on to proof of proof. With the new POP payout algorithm, what specific cryptographic techniques are used to prevent Sybil attacks on POP miners?
Not quite sure what the question is here. So POP is a permissionless protocol, so there's really no Sybil risk, as in, if you want to go and run 3 POP miners and pay 3 times the Bitcoin fees and get 3 times the rewards, you're perfectly entitled to do so. Kind of like Bitcoin mining, it's you can run 1 ASIC, you can run 100 ASICs. POP mining, you can run 1 POP miner, 2, 5. Obviously, with the new POP payout algorithm we're going to be implementing soon, which we've discussed a little bit in the past, but just as a refresher, is basically going to be a floating reward system. So if there's more than the target number of POP miners, which is going to be either 4 or 5, then if there's less than that, it's going to adjust up the rewards for future rounds. If there's more than that, it's going to adjust down the rewards. And so there's a upper limit of how many people can perform POP mining and actually have the economics make sense and get more rewards than the fees they're paying. And so that's a self-equalizing mechanism. So from a perspective of how many people are running POP miners, that's the real-world control valve there. But from a Sybil perspective, there's no Sybil protection because there's no need for it, because it's a permissionless protocol where we just want individuals to be doing this task, not necessarily caring about the composition of that group of individuals.
Yeah, basically, if the transactions go into Bitcoin, ultimately, from the sake of the protection that POP provides, they went in. Whoever did it is, not real, is neither our concern nor our business, and the controls are economic. Just like most crypto mining, the way traditional crypto mining works, it's economic. That's what solves it. If you want to do something that is not in your economic best interests, we can't stop you. And honestly, should we stop you? It's kind of up to you.
That's also pretty much every consensus protocol works. The exception, obviously, you have proof of authority, if you want to call that a consensus protocol. But also in some of the delegated proof of stake designs, there they care about Sybil protection, or what I'd call doxing, which is having a public identity tied to validators who could do something malicious in the system. Sort of you're not just staking assets, but you're risking your reputation, because if a lot of people in the community stake assets that their actions could put at risk, then there's that perceptive need to have more of a knowledge of who that person is that you're actually delegating to. But that's a specific limitation or tweak that you need to make, specifically in systems where you have one participant who could be malicious and steal money, do an attack, whatever, or just grief the chain, and them doing so would put other users' assets that they're staking to the validator at risk. Whereas with proof of proof, all we care about is the consensus proofs of Hemi get into Bitcoin, and we want to make sure that the economics are efficient, so the protocol is not overpaying for extreme redundancy that's not necessary.
And I mean, thinking about it the way a cranky old Bitcoin person would, if I need to know who you are to trust that the protocol is working, then the protocol's not working.
Yep, well said.
All
Yeah,
right.
very much second that. All right. Rely on the
no,
mute button.
please continue. No, please have at it, sir.
No, I was just going to reinforce what John just said. This is permissionless, so you do what you do, and if it costs you, that's your your prerogative. The end. There's a that's it. Welcome to blockchain, people.
All right. Thank you, gents. Second pop question. How does pop mining scale for higher transaction volumes as Hemi approaches mainnet maturity?
So the cool thing with proof of proof is you're basically just publishing a consensus proof of the current state of the Hemi network, and in the future with Chain Builder and having an L3 ecosystem, the states of all those L3s. And so the number of transactions that Hemi itself is processing, or Hemi's downstream L3s inheriting security through proof of proof, using Hemi as the security aggregation layer, the proof size of what you're actually publishing to Bitcoin doesn't change at all. So for people who are maybe familiar with some other Bitcoin L2s that are using Bitcoin for DA, for those chains, the more that they scale their transaction throughput, not computationally, but the actual size of the serialized transactions, that has a direct linear effect on the amount of space that they require on Bitcoin. We have a similar thing on ETH for data availability. So the more transactions the Hemi chain natively is processing, and the more data that is required to serialize those transactions, the more space we take in Ethereum DA. But on the Bitcoin side, for POP Bitcoin security inheritance, none of that matters, because whether there's one transaction or a million transactions, those are all summarized by the current consensus state of Hemi. And that is that fingerprint of, or the cryptographic commitment to that current state is all that needs to be posted to Bitcoin for POP and fork resolution.
All right. Hemi network specific questions. With the new daemon v2.0.0 refactor, what performance improvements have been observed in sequencer decentralization, and how does it integrate with upcoming Pectra upgrades for better fault tolerance?
I think this would be a great question for some of the other engineers on the team who have been working on the V2 daemon refactor to answer. Super high level, we made some improvements in TBC for the actual on-disk size of the index state. There's also been a lot of improvements that may not translate into performance improvements, but they're higher reliability, easier to understand, easier to reason about. There's a lot of technical debt from racing to mainnet launch that we were cleaning up in the V2 refactor. And it also has effects on people who are doing custom stuff with their pop miner, basically having better access to more data on the Bitcoin side, making it easier to build pop miners that do custom stuff. And also the daemon refactor simplifies the difficulty of running a node by letting you choose a more modular configuration based on exactly what you need. So if you need Bitcoin finality statistics, you can run the daemon responsible for that. But if you don't need those, you just want to run opgeth and opnode, so you have your own local RPC endpoint for doing DApp transactions, then you don't need to run the extra components. And so that's already been sort of the case, but this refactor makes that even more modular. And from a future sequencer decentralization perspective, making it, reducing the number and complexity of things people have to run to have quote unquote a node means that we're basically lowering the barrier to entry for people in the future to participate in decentralized sequencing. It doesn't really have anything to do with the Pectra upgrades. So those went live, most of the Pectra upgrades, I think those went live July 3rd. So we've been running on those for about 3 weeks now. There's really nothing in Pectra that's related to the daemon refactor. Those are two separate components at different layers of the stack. But as far as Pectra in general, it definitely adds some features on the EVM side that make building certain types of DApps easier. So things like, for example, onboarding users who want to, manage a Bitcoin asset position without having to have an EVM address. Now there's ways with gas abstraction where somebody could build that kind of protocol, where basically you could control an on-chain, on-Hemi position from a Bitcoin wallet by sending it instructions in Bitcoin transactions. And so while that, a lot of people familiar with the EVM environment, that may sound like a royal pain. There's applications, for example, for like MinerFi, where a Bitcoin mining pool may want to automate payouts of Bitcoin to users and let them manage, positions of, say, staked Hemi BTC or something similar. And so having the ability to do more cool things with gas abstraction with Pectra makes things in the mining fi space easier, and also gives more flexibility for DApp designs and certain abstractions that make it easier for people to interact with the network, even if they either don't have an EVM address or maybe don't have, ETH to pay gas fees, things of that nature. But unrelated to the V2 Hemi Network Daemon Refactor. Hey, I saw Jeff just joined. Hey, Jeff.
Hello, all. Our internal Hemi meeting just concluded, and part of the internal Hemi meeting was saying that all the missing people are over here. So this is where all the cool kids are.
Welcome to the party.
All right, end of my dramatic pause. One more Hemi network question, which is, I believe, a follow-up. It seems closely related. What changes are being made in the Daemon V2 refactor specifically for those running pop miners?
I can answer this one. Well, other than the main algorithm and the idea behind pop miners, for people actually running pop miners, a lot of things change. You no longer connect to BFGs, since we completely change kind of the infrastructure and how things are interconnected. So kind of the one who decides which keystones need to be mined is going to be opget now, so you'll have to connect to that. But when it comes to performance and things that the pop miners generally care about, we have some features and corrected some bugs. Like I know some people had issues re-mining keystones, so hopefully that should no longer happen. You also have the ability to estimate fees. You can still have static fees if you'd like, but we have ways to estimate fees dynamically. Performance should be a little bit better, and it's very modular now. So if you'd like to do different things or change your pop miner in specific ways, that should be relatively easy. And the way to get information about keystones, before you can only do so with TBC, and also that's currently the way we have it implemented. It's modular, so you could relatively simply change that and introduce a different Bitcoin source of truth. So TLDR should be faster, easier, and more modular for pop miners to pop mine in the future with these changes.
I think an important thing to highlight that Antonio mentioned there is moving all of the information the pop miner needs to get, moving all of that to, or at least for the perspective of new keystone information, getting that from opgeth RPC. So simplifying the number of different RPC interfaces that are relevant for different users. So now instead of pop miners connecting to BFG and MetaMask connecting to opgeth and some protocols needing access to some opnode functionality, now we've reduced that down to just opgeth and opnode, and then a Bitcoin, as Antonio mentioned, a modular Bitcoin interface, which right now is TBC, which is the same custom Bitcoin full node that's embedded in HVM. With the updates, you can also now run that as an independent Bitcoin daemon. But also the modularity lets you swap that out for other RPC providers. So if you wanted to use, the Blockstream API, for example, I'm not sure if we've written the adapter for that yet, but in the near future, swapping out the Bitcoin data source for other Bitcoin data sources will be much easier to do, and people could easily write custom adapters if there's another Bitcoin RPC interface that they want to use.
I think the Blockstream adapter is mostly there, since it doesn't have keystone information. It doesn't fully work, but it's over half the way there, and maybe at some point we'll change it, or someone can grab it and make changes. I think Marco wants to answer that, but I don't think your mic is working, Marco.
Yeah, Mark, if you're talking, we can't hear you.
it could just be a more dramatic pause than I've been doing, but it does seem like it's not working. All right, Marco, can you radio check? Yep. Looks like Discord's giving him the business as well. All right. We can come back to this if need be. That's totally cool. But let's talk about tunnels. For Bitcoin tunnels using BitVM for high-value assets, how does the dual custodianship model mitigate risks like collisions in multi-sig setups, and what fraud-proof mechanisms are in place for disputed transfers?
Good question. Not sure what you mean by collisions and multi-sig setups, but I'll just talk about the dual custodianship model in general, and then the dispute mechanism. So super high level, the dual custodianship model we talk about in the Hemi white paper is basically a combination of over-collateralized traditional vaults and BitVM vaults. So once we have BitVM deployed, all of the Bitcoin custodianship is going to migrate over to the BitVM custodianship system. So all Hemi BTC on the Hemi network would be backed by Bitcoin securely stored in BitVM vault constructs. But we're going to keep the mechanic for the over-collateralized custodianship system in place for doing stuff in the future, like we talked about briefly earlier with, BRC20s, runes, ordinals, so both fungibles and non-fungibles having that custodianship model available. Like I mentioned earlier, you can technically use BitVM vault constructions for fungible meta protocol assets, but in practice, it's probably not realistic for most of them just because of the total value of the deposits, not being able to justify the transaction fees, setup complexity, et cetera, of establishing BitVM vaults, and then making sure that there's sufficient people providing liquidity in those other alternate assets. Because if you just have a BitVM custodianship system, you can only do very large deposits and very large withdrawals. And so unlike the current over-collateralized custodianship system where a user could deposit 0.0001 Bitcoin, and that's perfectly fine. With the BitVM system, there's going to be a minimum of the value required to basically justify the whole BitVM vault setup. And so whether that's 1 Bitcoin, 10 Bitcoin, TBD, depends on network fees, depends on the decentralization of the Covenant Emulation Committee. But you solve that in the practical sense by having liquidity providers around that. So you'd have a liquidity provider who brings in, say, 10 Bitcoin, which justifies the BitVM vault construction setup costs and withdrawal costs in the future. And then that gives them 10 Hemi BTC. And then if somebody wants to bring on, 10,000 Satoshis, they can do that with that liquidity provider at a band using this liquidity wrapper around the tunnel system. And so they'd be able to send, that user could send 10,000 Satoshis to the liquidity provider on the Bitcoin network. There'd be an HVM level contract that monitors the deposits, quote unquote, of Bitcoin to the liquidity providers and automatically takes Hemi BTC that they have stored in the contract and distributes that to the user, minus some transaction fee. And then on the withdrawal flow, similar where you would burn your Hemi BTC, or in that case, not burn it, but send it to a liquidity provider. It'd be held in a escrow contract. And then that liquidity provider would have to fulfill that withdrawal on Bitcoin, and the HVM contract would monitor that user who initiated that withdrawal through the liquidity wrapper system actually got the amount of native Bitcoin on Bitcoin L1 that they were supposed to get before releasing that Hemi BTC in escrow to the person who's withdrawing through the liquidity system. And so I described that whole system because on the meta protocol side for, say, a BRC20 asset, you could put, $100 million if there was some BRC20 asset with, a huge market cap, you could put $100 million of that BRC20 asset in a BitVM vault. But if there's not enough people willing to provide liquidity for all these different assets, then you still have an issue with people being able to onboard and offboard those fungible assets. So most of the BRC20s, runes, things like that, once we add meta protocol index support for HVM, will be through the traditional over-collateralized system. But for some of the major ones, there could be migrations of those to BitVM custodianship mechanisms if there's enough demand and people willing to provide liquidity around it. As for the fraud-proof mechanism, basically that all comes down to HVM contracts observing activities on Bitcoin and lining those up with what's supposed to happen based on what's happening on Hemi. So for example, if you were to withdraw Bitcoin from a BitVM vault, and that BitVM vault, no operators were willing to front the liquidity, then the protocol would detect that there was never an operator who did the liquidity fronting transaction on the Bitcoin L1. And after a period of time, you'd be able to call that contract and dispute the withdrawal. It would look on Bitcoin, it would see that you're right, the operator didn't front liquidity properly, and it would refund you the Hemi BTC or reroute that withdrawal to another BitVM vault with a different operator set. Also, for similar mechanic for the over-collateralized vaults, if a Bitcoin vault provider doesn't facilitate the withdrawal within a certain period of time, then you dispute it. The HVM contract looks on Bitcoin, sees that the withdrawal was not done correctly, and then refunds you the Hemi BTC, and then you could go and withdraw that from a different vault. So all of the fraud-proof mechanisms, both for over-collateralized vault systems and BitVM vault systems, use HVM as basically the eyes to look at Bitcoin, validate that a withdrawal either was or was not successful, and then manage that either through rerouting withdrawal or refunding the Hemi BTC, and in the case of over-collateralized vaults, marking that vault as invalid or basically non-participating and letting people liquidate that vault for a profit for keeping the system solvent.
All right. Thank you, sir. Here is another tunnel question. With the new Rubik partnership for cross-chain routing, how will tunnels evolve to support intent-based protocols?
It's a good question. I'm not super familiar with Rubik. Rubik basically, my understanding is they basically do a ton of aggregation across bridges, dexes. I do believe they have some sort of intent-based account abstraction features. High level, basically protocols like Rubik, anyone who does cross-chain aggregation. So there's also protocols that build on top of, say, layer 0 and provide cross-chain transaction routing for, say, sushi swap transactions. Any of those things, they improve composability across the DeFi ecosystem. So, if there's liquidity on Hemi that, say, in, a Hemi BTC to USDC pair that somebody wants to take advantage of, but that user is on, Optimism, for example, these types of protocols would let people route that trade and basically benefit from the liquidity on Hemi, even if they're not, set up with a MetaMask wallet that's connected to Hemi and they have the assets on Hemi. So it should increase or decrease slippage, make markets more efficient, because you don't have assets sitting in isolation on Hemi, where if you want to take advantage of, say, an arbitrage opportunity, you need to already have the assets on Hemi to be able to do that. With these kinds of systems, now you can route trades through multiple different blockchains and benefit from the collective liquidity that they have in different pairs. So there's one chain that has better stablecoin liquidity and another chain that has better ETH liquidity. Now, from a single chain as your, the place that you interact with natively, now you can take advantage of those liquidity opportunities in other chains. And similar on the bridging side, which is kind of the underpinning technology below that, being able to route assets across multiple chains very easily instead of having to go through the longer withdrawal process, through the canonical Hemi tunnel, for example, makes it easier for users to move assets around, move them to where there's yield opportunities, things of that nature. So can't speak too specifically on Rubik itself, but protocols like Rubik, that's the net effect they have on DApp ecosystems.
All right, we have one further question regarding tunnels. What is the latency benchmarks for tunneling assets between Hemi, Bitcoin, and Ethereum in testnet?
Okay, so I'll talk more generally. So on mainnet, the latency, basically tunneling on the Bitcoin, there are different technologies. So the Bitcoin tunnel works differently than the Ethereum tunnel. In the future, there will be basically something that sits between them that unifies them. So you'll be able to tunnel assets from the Bitcoin side through Hemi to the Ethereum ecosystem, which somebody could build that today, basically that connective glue, but that's going to be part of the canonical tunnel design in the future with a future protocol upgrade. High-level Bitcoin deposits, it's basically just a matter of waiting for an adequate number of Bitcoin confirmations So depending on Bitcoin block time, but somewhere around 60 minutes to 120 minutes. Withdrawing, the operator has, with the current design, up to 12 hours to facilitate the Bitcoin withdrawal. And that's to make sure that, a sudden crazy spike in Bitcoin fees or some sort of temporary interruption on the Bitcoin network for whatever reason doesn't negatively affect vault operators who are not misbehaving. So 2 hours, 1 to 2 hours to deposit, maximum of 12 hours to withdraw on the Bitcoin tunnel side. On the Ethereum tunnel side, deposits are near instant. I think right now it's a 3-minute delay, and withdrawals go through the 24-hour optimistic waiting process. In the future, once we have BitVM, part of making BitVM work is having full ZK provability of the Hemi network. And so once we have that in place, we'll be updating the optimism settlement contracts to use those ZK proofs. And so initially, that may be 2 to 3 hours, and in the future, that could be brought down further. Could probably get as low in practice as 30 minutes to an hour, depending on the latency of collectively generating the ZK proofs. And then on testnet, the numbers for some of these things, especially the Ethereum withdrawal side, is a lot shorter just to make testing easier. But mainnet, that's where the deposit and withdrawal delays are really relevant to discuss.
All right, let's move on to L3s. As highlighted in the L3 security discussions, what are the first developer tools or templates available in Chain Builder for launching Bitcoin-secured L3 chains?
Good question. So Chain Builder is a future roadmap item, so we don't currently have any sort of SDK or code examples for anything Chain Builder yet. Those will be coming hopefully relatively soon, but definitely after like sequencer decentralization and BitVM. As far as what it'll look like in the future, though, basically it'll be a out-of-the-box deployable version of an L3 with some customizability, and then over time we'll increase that customizability and offer more options. So if you look at some of the services for launching your own rollup, you can go in and you can configure, okay, do I want to be a optimistic rollup or a ZK rollup? Do I want to have a centralized sequencer? Do I want to have some sort of use like a shared sequencing system? Do I want to use Ethereum for DA? Do I want to use Celestia? Do I want to use Espresso? And so as Chain Builder evolves over time, we'll add more of those features and configurability options. The eventual super future state of Chain Builder is basically this library of a ton of different variants of different L3 stacks. So everything from some sort of very centralized but very high throughput, low cost chain defaults that maybe are optimized for a application in on-chain gaming, to another variant that is super optimized for decentralization, but it's slower, lower throughput, higher cost to use because you have to pay the sequencers for your network to sequence blocks. You're using Ethereum for DA, and so there's increased DA costs compared to some other DA system. And then eventually, the super end goal is to have a shared sequencing, shared DA system. So basically, people would stake Hemi tokens in the quote-unquote codename converged staking system, and they would opt in to be participants who are providing shared sequencing, shared DA for Chain Builder chains who want to use that. And then that it's a way to decrease costs while still getting relatively high levels of decentralization and security, but also there's interoperability opportunities when you have a shared sequencing layer, because you have basically mutual finality with all of the other chains that are using that same DA system. So developer tools, going back to the original question, will basically be, here's pre-configured examples of chains. Maybe they have a different VM environment, different sequencer setup, different DA system, and then you can either launch those as is, or you can take those and customize the code. So one of the things that we want to do, in that with the emerging practical realities of ZK proofs being efficient enough and battle tested and audited enough to be extremely reliable and relatively performant, we can open up basically the limitations on what an L3 can customize while still being compatible and interoperable with other chains in the L3 ecosystem. So if you look at something like the current Optimism superchain approach, and they are moving towards loosening those reins as well. But they basically require everybody to follow very strict adherence to the same protocol for how to derive the L2 from Ethereum DA, how the L2 is sequenced, how it's settled, so that each chain can basically simulate the other chains by following its own protocol. And with proof of proof to some extent, and also with ZK proofs becoming more realistic, we can remove a lot of those requirements, basically let L3s customize whatever they want as long as they meet some certain interoperability standards for how they relay messages, how they communicate state, and how they perform fork resolution.
All right. On to our next L3 question. How does Bitcoin security as a service ensure economic alignment against 51% attacks?
Good question. So one of the cool things, I mentioned this earlier with proof of proof, is the amount of space that you take on Bitcoin doesn't increase in any way related to the actual throughput of the transactions that either Hemi itself or in the future L3s in Hemi's chain builder ecosystem are using. And so from an economics perspective, that basically means the more chains that have more transactions creating more economic value that are all using Hemi as this central security aggregation layer, they're basically collectively bidding for space in the Bitcoin blockchain. So the way that we're going to design proof of proof on the L3 side is pop miners who are pop mining at L3, they're going to be paying fees in Hemi tokens to publish data to the Hemi network. And then that's going to be stored in sort of a special area dedicated to just pop information about chains, basically a different data structure. Kind of similar in some ways to the separation between on-chain data versus DA blobs on Ethereum. Not with that construct, but kind of similar metaphor at a very, very high level. But basically, L3s are all publishing data to Hemi. Hemi's publishing a cumulative cryptographic commitment to all of that data to Bitcoin. And so all of the chains and all the economic value that they're all independently creating, a portion of that basically flows through in Hemi's collective bidding power to make sure that it can get proofs onto Bitcoin. So if you run the blockchain ecosystem forward a decade, say, Bitcoin fees are astronomically high, for a single chain to secure itself to Bitcoin with POP and have, reasonable decentralization or redundancy would cost, $100,000 or $1 million a day. Probably never going to get there, but theoretically possible. Now, if you had 1,000 chains that are all each independently creating tons of economic value, and they're effectively sharing the burden of that proof cost, then each chain's getting Bitcoin finality, Bitcoin security inheritance for 1/1000th the cost of a chain going independently and not going through a security aggregation layer. So that's the economic incentive alignment, is basically all these chains with all the value they're all independently creating. A portion of that value is flowing through to collectively bid for block space on Bitcoin to secure all of the protocols that are using the same security aggregation layer.
And remember, on the other side of it, Hemi, and therefore anyone who's using Chain Builder to build their chain is a good, normal, quote unquote correct player in the Bitcoin ecosystem, which means nothing we do is going to break the general model of Bitcoin. So, Bitcoin still has its own economic, existence, no matter what, which has its, your own concerns about 51% attacks or anything like that. We're playing nicely with Bitcoin and are providing the regular transaction fees to it. So, there's no concern that any of this messes with the normal 51% attack concerns of Bitcoin. If anything, since we're providing, a nice steady drip of transactions, it just helps reinforce the way miners are supposed to be working normally there.
Yep, exactly. One of the things that I know I've mentioned, I'm not sure if it was on a previous engineering AMA or Midweek Max, but when you look at the Bitcoin protocol and the way that it evolves, is probably anyone who follows, followed SegWit or Taproot activation, TapScript activation is familiar. Bitcoin's protocol moves very slow because it's very conservative. And one of the major risks that many people in the Bitcoin ecosystem of influence on protocol upgrades, socially at least, look at is, does this update introduce some sort of negative economic externality? So when you look at, say Ethereum, going back to 2015, the word MEV was not a thing, right? There was theoretically, you could maybe go and front run a, trade of some counterparty meta protocol asset or whatever. But it wasn't something people were actively concerned about. It wasn't something that, to my knowledge, anyone was actually any Bitcoin miners were actually exploiting to try to, extract additional value from including or not including certain transactions in any way other than just looking at the fees they pay versus the space they take up in the block. And so with Ethereum and all of the additional complexity and possibilities of having a Turing complete programmability environment, that introduced way more opportunities for things like MEV extraction and, in the worst case, consensus protocol attacks to, basically do arbitrage through stolen time, right? And so if you can go and reorg the Ethereum chain 3 blocks, that's 36 seconds, where you could unwind a DEX 36 seconds and trade against the price from 36 seconds ago. And anyone familiar with, traditional market trading, if you had a 36-second advantage in, conducting a trade, that's absolutely huge. There's teams dedicated to building custom, FPGA systems for high-frequency trading, where the exchanges actually measure the length of copper cable that they give to each of the people independently running these high-frequency trading bots to make sure they all have the exact same latency. And so, compare a 2 millisecond advantage you can get with FPGA optimizations for algorithmic trading with a 36-second advantage from being able to reorg 3 Ethereum blocks, right? Order of magnitude difference, but it's the same fundamental attack surface. And so, getting back to my original point, sorry, I'm rambling. The upgrades for the Bitcoin protocol, everyone's really conservative about anything that could add MEV. And one of the unintended side effects, which I personally don't think is an issue, but some people are concerned with and point to as the issue with changing the Bitcoin protocol, is that TapScript introduced much better ways to store large amounts of data on Bitcoin, basically using Bitcoin as a DA provider semi-possible, in the sense that it doesn't really scale, and it's very expensive, but it is doable. And one of the side effects of that is now there's potential MEV leakage into Bitcoin's consensus, because if you're able to reorg 3 Bitcoin blocks, then that gives you the ability to modify what was stored in Bitcoin DA and basically reorg L2s using Bitcoin for DA. And so, while I don't think that's a practical concern, it is one of the things that Bitcoin's protocol development in particular is very sensitive to. And the way that Hemi uses Bitcoin, not using it for DA, but using it for this second layer of finality with proof of proof, is basically the best way to interact with Bitcoin in the way that creates the least MEV extraction possible, because people can't attack Bitcoin consensus in a practical sense to manipulate stuff on Hemi, or at least doing so would be much easier to do through, short-range reorgs attacking Hemi's native consensus. By the time you're talking about reorging Bitcoin to attack Hemi, you've also had to reorg Hemi's native consensus and do an attack on Ethereum's consensus protocol. So Bitcoin itself is very insulated from any MEV risks, again, at the consensus protocol layer emerging from the way that Hemi is integrated with Bitcoin.
All right. And for the final L3 question, when deploying custom chains. What the hell am I talking about? When deploying custom H chains, what are the key trade-offs in data availability, e.g., using Ethereum blobs versus custom DA layers, and how will Hemi support ZK rollups on L3 for privacy-focused applications?
That's a really good question. Actually, pretty much 2 questions in here. So the first one is, what are the trade-offs that H chains can make? And the question specifically asks data availability, but there's, I'd say, 4 major categories of trade-offs, DA being one of them. and they all have effects on the chain's throughput, the chain's security, and the cost, the security, and the settlement time. And so, generally speaking, a good rule of thumb is the more decentralized and secure something is, the more expensive it is to run, the more expensive it is for users, and the less it's going to be able to scale, at least natively scale on its own layer. There's obviously, Hemi can scale through tons of L3s. L3s can each scale through having tons of L4s. You can also do off-chain scalability mechanisms, things like Lightning or the Lightning equivalent on EVM networks. But basically, you have these different trade-offs you're making that change all those parameters. And so if you want, a really fast chain that can process 10,000 transactions a second, it's going to be very hard to have any sort of decentralized sequencing system. And so looking at, the practical realities of the blockchain ecosystem today, chains that have really, really high throughput, basically the only way to do that in a semi-decentralized manner is with some delegated proof-of-stake system with a very small amount of very powerful validator nodes that everyone's delegating to. And, that setup allows each of the validators to peer directly with each other instead of having, 4, 5, 6 layers of separation between some validators like you do with Ethereum consensus. And so you're able to scale extremely well, but you can only have a couple active validators. They have outsized control over the network's consensus, over extracting MEV from users, and they have to run extremely powerful hardware, which acts as another barrier of entry to people running decentralized nodes in the network. On the DA side, DA is one of those things where to some extent, it's basically your consensus security. There's multiple layers to consensus security. So on Hemi, for example, there's 3 layers, at least once we decentralize the sequencer. There's Hemi's native consensus. So are you able to actually create a alternate chain history by controlling a certain amount of Hemi's native consensus stake weight? Then there's the Ethereum DA side. So once that data gets published to Ethereum, do you have either the ability to censor that data from getting into Ethereum, doing a censorship attack on Ethereum itself, or do you have the ability to reorg Ethereum and remove some data from DA that Hemi published there? And then you have the Bitcoin finality proof-of-proof layer, which is of the data that gets published to Ethereum DA. Is there any way that somebody who's able to manipulate that DA could reorg the Hemi network? And in order, once something gets to Bitcoin finality, and then to do that, you need to actually 51% attack Bitcoin itself to retroactively insert, alternate proofs of the Hemi chain to this alternate version of Bitcoin that you're creating and convincing the Bitcoin network to reorganize onto. And so DA, it's important for security. Most chains use it as basically their primary consensus mechanism. For DA, basically Ethereum is, I'd say, the gold standard of DA from a security perspective, but it's expensive. And while Ethereum is going to scale it a lot in the future, it's relatively crowded right now, and there's a lot of L2s using it. There's competition. We've seen at least 2 or 3 different extreme fee spikes in the DA markets. The first one was with blob subscriptions, which was basically people taking all of the ordinals energy and trying to do on-chain NFTs using blob data. And then there's been a couple that were due to L2s basically testing extremely high throughput and being willing to subsidize extremely high DA costs to do so. So the trade-off there is basically you can use Ethereum, but it's going to be more expensive. Hemi optimizing for security, we use Ethereum DA. The trade-offs make sense. A lot of L3s may want to use something that's cheaper and still relatively decentralized, like a Celestia or an Espresso. Those are 2-3 orders of magnitude cheaper, and they're still very secure, but they don't have $80 billion of staked ETH that are securing those DA publications from reorganization. Or chains could choose to, some L3s and even some L2s actually don't have a DA system. And so you can just rely on nodes to basically communicate chain data to each other. It's basically the same DA guarantees that, just your own standard L1 would have. But in the, multi-chain settlement context, that gets a lot scarier because you have all this interconnectedness with other protocols. And so not having a reliable DA system makes interoperability much riskier. So if, we would not want high volume asset interoperability from Hemi to a chain that has, no DA system, for example. So the trade-offs there is basically cost. You can have pretty much the same throughput no matter what DA system you use if you're willing to pay for it. Obviously, there's a limit to how much data can get published to Ethereum in any period of time. And so if you independently as a chain were to get close to or exceed that, you would have to go to a different DA system. But high level, basically, DA, it's security for your chain. It's that intermediate consensus security. And most L3s on Hemi will probably choose to use alternate DA systems just because of their position. They're optimizing, in most cases, probably for higher throughput and lower costs. But if they want, the exact same security and speed to each level of security, then they can get that by paying a little more and using Ethereum. The other trade-off with L3s is how much gas you let people consume per block. And so that acts as a centralizing feature. The more gas you can consume per block, the harder it is to run a node on the network, the harder it is to run a validator. So if you have decentralized consensus, then, kind of like Solana, for example, you get a very small amount of very powerful validators who can actually meet the requirements needed to run a node on the network. And it also introduces potential risks of, different, if there was a misprice in some of the gas, for example, I think there was a time we saw this on Ethereum where one of the pre-compiles was grossly underpriced. And so by abusing that, people were able to make a node do way more computation than the worst case that people assumed when they set up the gas pricing. And so Ethereum had to make some modifications to some of the gas pricing there. And so if your EVM is well below the computational limits of, an average computer, even if there is one of those exploits, it's unlikely that even abusing it would still overwhelm a machine that has much more computational power than it expects to need to have to process EVM state transitions. Whereas if you're pushing the limits of what a powerful computer can do with your default gas setting, then any sort of those exploits can basically completely destroy the chain, fragment consensus, cause nodes to go offline, stuff of that nature. So very long rambling way to say there's different trade-offs for different things with L3 design. People focused on, things like gaming, they would want to use a very cheap DA system and probably have a centralized sequencer. Somebody who's doing, very large transaction settlement, maybe very deep liquidity pools for a few specific assets. They would probably want to use, Ethereum for DA and, have a decentralized sequencing system with similar consensus protocol to what Hemi is going to be using once we decentralize our sequencer, which is basically a variant of Ethereum proof of stake adapted to work in an L2 context. Sorry, I went way off the plantation with that answer, but hopefully that all made sense.
All right. Thank you for that, sir. I see we have one final question. It's in the other category. All right. For new features like debt vaults, what audit findings have emerged regarding programmable loan risks, and how will slashing mechanisms and publishers/challengers prevent invalid states in a live environment?
Not quite sure what this question's asking. So the debt vault setup that I think you're referring to on Hemi, it's basically a system for coordinating loans that are enforced by external mechanics. So, for example, having like a legal contract and just using the debt vault loan system is basically a way to do the on-chain counting, make the interactions between those users easier. But it's unique in that it's not enforcing any sort of rules on those loans that you're taking out versus, something like Aave is, looking at collateral, you have liquidations of loans, stuff of that nature. So it's a fundamentally different product aimed at a different use case. So for example, if, I have a friend who wants to extend a line of credit to me that I can use to take advantage of arbitrage opportunities, we have a legal agreement in the real world that he could enforce, but we're using the debt vault system to coordinate me borrowing from that line of credit, repaying it, calculating the interest that I owe him for the amount of assets times the amount of time that I had taken those out on that line of credit. So it's a fundamentally different system. As for how it relates to slashing mechanisms, publishers, challengers, the debt vault system is not enforcing any sort of rules because that's not the type of loan market it is. So that's not really relevant. The only main thing that's relevant is just making sure that there's no reorgs of the chain that change loan positions, and that's basically just the same consensus security that you need for any DApp.
All right. I believe that brings us to the end of questions. So I'm going to just say a big thank you to everyone who turned out today, in the community, from the engineering team, and I really don't have a good outro. I'm so used to Midweek with Max, so I'm just going to pitch it back to our engineering team for outros. And again, thank you all so much.
All right, awesome. Thanks everyone for showing up, and take a moment if anyone on the engineering team wants to add any additional thoughts, comments, talk about something they're working on or excited about. And other than that, huge thanks to everyone for showing up. We'll be doing these probably monthly. And also keep an eye out for the HBitVM white paper coming soon. And we'll do a special AMA to field questions and dive into the very interesting details of some of the cool stuff we're doing on that side.
And that's going to be an extra nerdy AMA. If you thought these were techie and nerdy, just wait.
I might need a cheat sheet for that one. I'm not going to lie. But yeah, thank you all so much. We really appreciate it, and we will see you around.
Maybe we can assign an engineer to sit with you to shadow you during that one.
Not it.
Yeah, not it.
Hell? What? What the hell is this? Thanks for the support, guys.
If someone calls Not It, I assume I need to call Not It as quickly as I can after.
That's fine.
I just unmuted, so it was perfect. So you guys invited it.
That was some damn good timing, Marco.
Well, I know. I was going to say bye, but then I heard that I was not volunteering.
Well, fine. I'll go commando. I'll just do it by myself. That'll be fine.
Thanks, Rick. We do appreciate it.
Yeah, I appreciate the hell out of support, guys. Thank you.
I will support you, Rick. I promise. I'm just not as smart as Max, so I can't do it.
We'll figure it out.
We'll figure it out. We'll take this offline. This is just Biggs is going to kill me for this outro. But anyway, thank you all again so much, and we'll see you soon.